Hi, everyone. My name is Anish Asthana. I'm an engineering manager with the OpenShift AI group at Red Hat. I've been working in the cloud-native AI space for the last 7 years or so now.
Hello, and I'm Roytman Alexey. I work for IBM Research, something like 25 years. Started with IBM middleware, after that cloud infrastructure, cloud solutions, and currently my focus on data processing automation.
And today we'll be talking to you about foundation model data engineering using Kubernetes. So to give a brief overview of the agenda, we'll be introducing what these data processing workflows look like first. Then we'll talk about how projects such as KubeRay and Kubeflow Pipelines can be used to scale up and productionize your workflows. Then we'll kick off the demo and then introduce another project called Data Preparation Kit, which makes it much easier to build these systems out.
OK, so let's talk about data preprocessing workflows. The workflows usually starts from data corpus access, and in our case, we use Parquet files with arrow tables format. And when we work with large data sets, duplication or semi-duplications are often present. And therefore, the first steps in the data processing, it's working with deduplication, which can be exact deduplication or combination of exact or fuzzy deduplication. After that, usually might be language separation and filtering, which allows to proceed with next steps based on a specific language. Depends on the data input. Some annotated transformers can exist, for example, to check that data doesn't include personal identifiable information, PII, or hate, abuse, profanity language, or just check that quality of documents. These transforms, at least in our case, are mutual. They do not depend one to another, and we can execute them in any order or even in parallel because they write data in separate columns. We will see that in the next slide. And usually the process ends with filtering and tokenization. Like I said before, some steps can run in parallel and merge at the end. Another type of parallelism can be applied based on natural language, because after, and we're going to demonstrate it in demo, after language separation, all next steps can be run independently and execute for each language.
So as Alexey talked about, right, like you have lots of pre-processing stages in your pipeline. These stages may or may not be linked to each other, and they can operate on data at a very wide variety of scales, right? It could be at the megabyte, gigabyte level just for like local development and testing, or at actual terabyte scale for when you have lots of data and you're doing actual data transformations. One of the issues that we were running into was how do we make it easy for our developers to do quick local development cycles on their laptops and then scale up to the cloud, right? The solution we elected to use for the most part was Ray and KubeRay. There's obviously options like Spark, Dask, and all of that stuff. We liked KubeRay. So KubeRay is an operator that brings core Ray concepts such as Ray clusters, Ray jobs, and Ray serve to Kubernetes. Since it's an operator, it requires custom resources and YAML, which most of our users actually hated. We got around that by using something called the KubeRay API server. And all that does is it allows your users to make direct API requests and then converts them into the corresponding YAML objects on the cluster. This is acted upon by the KubeRay operator to do whatever you need it to be doing.
All our array-based transforms follows the driver worker paradigm. And the driver, when it starts, reads all the input files names or object names in the case of S3, and dispatch tasks to workers, which are implemented like array actors. Sorry. Unlike Spark, we don't have partitions here because when a worker finishes proceeding a file, it asks the driver for the next one. And this approach helps us to prevent slowdown when file sizes vary significantly. We use a separate array cluster for each different data processing task, and which allow us to create task-specific images and avoid dependencies conflicts, and include support for legacy libraries, for example, even Java modules. Each worker reads and writes data separately, and this spread of network load between actors, so in the end of the day, array, at the end of the day, Kubernetes pods and nodes. Before going to KFP automation, and in order to summarize very short introduction to Ray, we want to share with you our most extensive task that we executed. It was a deduplication task, fuzzy duplication task with almost 8.5 billion documents, with compressed storage 23 terabytes. The task reduced the documents and storage something like 35–40%. But the most interesting part here is the array cluster configuration. It included 7,500 CPU cores and 56 terabytes of RAM. And the task spent almost 40 hours.
So I just noticed that the slides look a little funny. We'll make sure to upload slides with the correct template afterwards. I don't know what happened. Anyway, so we just talked about how KubeRay can be used to scale up your workloads, but how do you orchestrate these long-running ETL jobs, right? Your first option, obviously, is just running things locally, but that's not very resilient to like PTO and vacations. The next thing we looked at was something like Kubernetes jobs, which got us most of the way there, but the user experience wasn't quite friendly enough for like a data scientist to really dive into, right? Like Kubernetes, like jobs, they didn't have a very great UI for them. This is why we started using Kubeflow Pipelines. While this talk is focused mainly on data engineering, I do want to like reiterate that, or iterate, that Kubeflow Pipelines can be used for orchestrating your entire MLOps lifecycle. There's three main ways to create steps or components, as they call them in Kubeflow Pipelines. You can have normal like Python decorated components, very easy to get started with. And you can have very complicated, like completely custom containerized components as well, right? So if you have Java code that you need to be running for some unfortunate reason, you can do that. Yeah, that looks good enough. So here's a picture of the UI. Here, again, the specifics of this DAG doesn't actually matter, right? It's just like a bunch of steps. They're all connected together. We have some users of Kubeflow Pipelines who have hundreds or even thousands of components in a single pipeline. Why they do that? It's full flexibility, right? You can do whatever you need to be doing. The other thing I want to call attention to is within the UI, again, you can see you have input parameters. You can look at the logs while it's running. All this kind of stuff, right? Yes, you can do this from the terminal, but it makes it much easier for people who aren't familiar with Kubernetes to kind of orchestrate and build these jobs out. Now, say I want to explore Kubeflow Pipelines, right? Maybe I don't want to learn a new Python SDK for it. Well, the answer for that is Elira. Elira offers a pretty easy to use drag and drop interface for creating complicated DAGs. You just put them together, or you can specify any input parameters you need, outputs, sequence, all of that fun stuff. So if you're nervous about trying it out, use Elira. So I want to briefly sum up some of the key benefits we had from using Kubeflow Pipelines for this group. The first one was modularity. Our workflows were broken up into like smaller reusable chunks that we could chain together to build very complicated pipelines. This made debugging very easy since there was individual pieces of work, and when something was breaking, you knew what was going on. It also introduced a lot of niceties around reproducibility. KFP runs are kept around for days, weeks, months. You could see what input parameters went into it, what the output artifacts were, view all of that in the UI. So as a data scientist, again, when you want to see how something has shifted over time, it's very easy to do that without having to go anywhere else. Lastly, again, I keep talking about the UI, right? Visualization capabilities in KFP made it very easy to build out neurons, to track experiments, and to just troubleshoot any issues we were having. All of these came together to allow us to replace the data scientist with operators. This way, data scientists could focus on problems that they're really good at solving and that bring maximum value for them. And the operators could do what they're good at, like just running stuff. Next up, Alexey is going to be talking about some of the pipelines they've built.
Okay, so Anish talked about modularity, and in order to provide reusable components and modularity, we implemented all steps like a simple pipeline. And we have first step, it's argument preparation, because some arguments we need to proceed during the runtime instead of compilation time. After that, we start Ray cluster, and it's not we actually, it's a KFP component. And when the Ray cluster is ready, KFP submits the job to it. And when job is finished, the cluster is stopped or undeployed. The undeployed component is implemented like exit handler. It can be similar to in the code for like try and finalize. Final to guarantee that cluster is undeployed independently on status of execution of job, if error or success. And all these three components, like deploy Ray cluster, execute job, and destroy the Ray cluster are a shared component, are the same for all data preprocessing steps. The difference only in arguments that we provide to them. We can see here an example of the simple run, and with all of the three components like we mentioned here, and how we create the components. Okay, we created simple pipelines, but our target is to automate the entire process, maybe several data preprocessing steps or all the steps. So we create multi-step pipelines, or super pipelines like we call them, where each step is a nested pipeline, or nested simple pipeline for specific data preprocessing step. And you can ask how we implement nested pipeline if we work, for example, with KFP v1, because nested pipeline were introduced in KFP only in version 2. So we use KFP SDK to execute pre-installed simple pipeline. And as a result, with KFP v1, we have n+1 runs, where n is the number of steps in the multi-step pipeline. For example, here, we will get 4 runs. And in the demo, we are going to show you how we do it. And it's a perfect time to go to the demo. I think it's this one. Okay. Maybe let me stop it for a moment. We can see here we have several pipelines deployed on KFP server. It's KFP v1. The first one, it's a multi-step pipeline. Just in a moment I will show it. And all others are simple pipelines for specific step in data preprocessing. So we go here. And we can see here that first we run document identification, after that exact deduplication, and after that language separation and filtering. And then we have annotated transforms for document quality annotations. And we run 3 different sub-pipelines for different languages, for English, Japanese, and French. Okay, so, okay. And we can see here for each simple pipeline, we have the same pattern with 4 steps like we discussed before, and we didn't have any runs. Now we execute the super pipeline, we start the run. Okay, and we can see first run, it's the run of a multi-step pipeline. In a minute, we'll have another one. Okay, it's, and meantime, I will demonstrate you the KFP v2. It's exactly the same super pipeline, but here we have KFP v2 supports nested pipeline. Here the real nested pipelines. We can go into the UI to see the parameters, and we can execute, start the run. And another example here that we demonstrated, like Anish said, that we had previous run, and we just clone it to run it again. So we have a history of execution. And we can see the first step is running now. Go back to KFP v1, refresh, and we see that in addition to super pipeline, document ID is running, and almost here it's done. And we go back to runs, and we see that exact deduplication is starting. And we can see, go into the super pipeline, multi-step pipeline, we can see that the first step is done, exact deduplication is done, and now the language identification is starting. And we can see for each step the different runs on the dashboard. For KFP v2, it's simpler. We have only single run, and we can see the status of each steps on the same view. So it's language identification is finished, and now we have a split for each languages. For English, Japanese, and French, the filtering is done, and now we run its document quality annotators. The same on KFP v2, just refresh the screen, and we have language identification is done. The Japanese filter is starting the first, after that others, and meantime, we return back to KFP v1. We see that the process is done. And if we go to the run, we can see that instead of a single run, we have a lot of different runs. For each step, we have a separate run, and we can go into the, if we want to runs and check it. On KFP v2, the Japanese filter started first, so now the quality for Japanese is started. And other quality document annotators are running, and this is done. And if we go to now to runs, just demonstrate that all the picture, and just a moment. We have only 2 runs here, because one it's the previous run, and the second one it's that we executed. I think we're done with the demo. And we go to discuss the history of our work. When IBM started working on data preparation for large language models, each data scientist worked independently. They created proprietary Python scripts, executed them on Ray, on Spark. Okay, with KFP, we automated the process of start and run, but the data processing scripts stay proprietary, and it's great a lot of problems. For example, for newcomers, developers wanted to create a new transformer. He had to know how to work with the infrastructure, how to work with Ray, how to work with Spark. And in order to resolve this problem, last year we submitted or published Data Prep Kit, open source project that is designed to provide, to help to implement data processing in a consistent way. It removed need for module developers to implement common tasks like access to S3 storage, generate metadata, unified shared parameters. And the most important, it wraps running framework. So the developers now don't have to know deep knowledge about Ray or Spark. It simplifies, add new modules. And of course, we have KFP automation for the modules on the same project. DPK was checked in production. It was used for IBM Granite LLMs creations. And 2 weeks ago, DPK joined Linux Foundation Data and AI community. This picture is from our paper that was published last year on Data and AI, Big Data Conference. And we can see here a list of different transformers. It's not all of them that we have in DPK. We have much more. But most important part here is that we have different runtimes. We can run it on Python, just on the laptop. We can run it on Spark. We can run it on Ray, and KFP automation for automated process. And DPK is not only for fine-tuning, data preparation. It can be used for RAG. We have some examples in the project. And actually,
yeah, sure. So here's some QR codes you can scan or just Google for these. The first one takes you to the Data Prep Kit project, and the second one is a link to the Kubeflow community. Again, both communities, we're really trying to grow them out. So we welcome contributions. So let's get in a few seconds for that. I'd also like to call out this is Alexey's first time giving a presentation. So congratulations. All right, we have 7 minutes left. So any questions? It looks like there's a mic in the middle, I think.
Hello. All right. Yes, in Kubeflow upstream, we have experimental integration for Ray as well. So did you use that, or did you build your own Ray?
Sorry, could you repeat the second bit a bit?
Did you use the experimental integration in upstream Kubeflow for Ray, or did you build it yourself, the KubeRay integration?
So this was using vanilla KubeRay. There's no additional extensions really on KubeRay. There were some features that were added to the KubeRay API server and KubeRay as part of some of this work, but that's all upstream.
Actually, we have addition, but not on KFP, or not on KubeRay, but the connection between KFP and KubeRay. How to execute the three components that I mentioned here, to start Ray, to submit the job, and to destroy the cluster.
Yeah, for example, the permissions to do that, I think they're also upstream, so that you could maybe reuse. And the second question is regarding Spark. Did you try something similar with the Spark operator as well?
I'll let you answer that one.
Yes, we had discussions about the Spark integration with KFP and actually checked the Spark operators that are currently part of KFP project, but meantime we use only Ray with KFP.
So the Spark operator is a little more recent to the Kubeflow project. So when we started on it, KubeRay seemed to be in a better spot. So something we'll probably revisit in the future.
Thank you.
Yeah, thank you.
Hi, thank you for the presentation. Being new to the Kubeflow, I have a question. And it makes an impression that maintaining this framework on Kubernetes is a pretty large effort and requires, significant investment of skills. So I'm wondering, for the specific pre-training task that you demoed today with the Kubeflow pipelines, which is obviously working, could it be sort of implemented with a more lightweight components without deploying the whole Kubeflow, so make it more sort of smaller footprint, more accessible? Or it has to be full-blown deployment of Kubeflow pipelines?
You can use DPK without KFP. You can run it on just in Python or with Spark or with Ray, but it will be single step. And in the examples we have integration with Jupyter notebooks. It's a kind of pipelines to connect the steps together. And currently we check if it can be maybe with LangGraph.
Okay.
LangGraph and LangFlow.
So the same script could be run from the Jupyter notebook essentially, and that will work as well, as long as it uses your plugin, right?
Correct.
Okay.
Yes.
Thank you.
All right. Well, we're basically at time. If anyone wants to talk in more detail about any of this stuff, feel free to come by. 30 minutes is not a lot of time to go into tons of detail. So, yeah, thank you for attending.
Thank you.